Okay, let's finish up here with talking about how to sketch polynomials without a calculator. So we're going to put everything we learned together. We're going to determine the end behavior, and we're going to graph that first. Then we're going to factor and determine the zeros. All right. Once you've done that, you're going to use multiplicity to determine what happens at the zeros, and then piece everything together. So a couple things to keep in mind. The reason why I showed this picture, and thanks to the website shelovesmath.com, great website for some math stuff. I use it all the time. On the left is like what your sketch might look like, and on the right is what it would look like on a graph. So the point of me pointing this out is that without a calculator, and without knowing calculus and how to find relative minimum and maximum without a calculator, and without knowing how to find derivatives, so pretty much knowing everything you know now, you don't really know like where it's gonna turn and go back to the zero. So when you're sketching it, it's not, don't stress over that part. All right, if your graph looks like this and this is what it looks like on the calculator, you're doing a great job. All right, that's 100% correct. All right, so again, you can't really tell where this point is here without a calculator, or you know. All right, I think you get the picture. Now, let's look at how we would graph this, all right? We would look at the zero. Well, let's look at the end behavior first. So I would see it's first degree, third degree, first degree. If they all got multiplied together, the degree would be 5. So no matter what, we're going to go in opposite directions. All right, then the leading coefficient is going to be positive if we multiplied everything out. So we put the plus sign, we put an up arrow over there, and since the degree is odd, we put a down arrow over there. Alright, then we would look at the factored form and find the zeros. So you got a 0 at -2, a 0 at 1, and a 0 at -4. Alright, I highlighted them the wrong way, sorry. Alright, then to find the y-intercept, you couldn't really tell right away. You would have to plug 0 in and then evaluate that, and you would get y is equal to -16. Alright? Now we're just going to connect the dots, but also keeping in mind the behavior around the zeros. All right, since x plus 2 had a multiplicity of 1, there's going to be like a normal behavior right there. Since x minus 1 had a multiplicity of 3, it's going to kind of flatten out over there. And then since x plus 4 had a multiplicity of 1, it's going to go flat through there. So if we connect the dots, all right, that would be a good sketch of our graph. Okay, one last example. So sketch f of x. Now this would be a 4th degree polynomial, and if we were to multiply it out, the leading coefficient, or the leading term, would be 4x to the 4th. So it's going to be positive. So if this is our final graph, I know it's going to rise to the right. And also, if we multiplied it out, the degree would be even, so it's also going to go up to the left. Alright? If we look for the y-intercept, alright, we plugged in 0 there, 0 there, 0 there, 0 there. Alright, f of 0 would become 1 times -3, which is -3. Alright, so we have the y-intercept is -3. Okay? Now, to figure out what the zeros are, we need to factor this. Alright, so next year when you're in math analysis, you need to be able to factor this without really just in your head pretty quickly without having to spend too much time. So the way I do it is a guess and check method. Alright, now I'm lucky 2 is prime, so I know it's going to be 2x times plus something times x plus something, and then also 2x plus something times x plus something. Alright, then I know that the last number, the last two numbers here and here have to multiply to 1. And also, when you multiply them to 2x and x, have to add to -3x. So I'll put a okay, so there has to be a -1 here and a -1 here. The only other option would be a +1 and a +1 because they both multiply to +1. Alright, but that wouldn't give you a -3x. So that's what goes there. And then these numbers have to multiply to -3, but you have to make sure you get a middle term of 5. So if I put a +3 here, I would get a 6x. But then if I put a -1 there, that would add to be 5x. So there you go. Now, if we were to write this in a simplified way, we could write it as 2x minus 1 squared, because there's 2 of those, alright, times x minus 1 times x plus 3. Okay? Now I'm going to take these zeros, alright, such as 1/2, okay, and 1, and -3, Okay, not really drawn the scale, but that's okay. Alright, and now I'm going to complete the dots. Alright, so I'm going to connect my end behavior on the bottom left over here with my upper right. So I go through -3. Alright, it's going to be normal behavior here because there's a multiplicity of 1. Then eventually it's going to come down, not sure where. Alright, we have an issue here. Okay, I apologize. Everything I said so far in this video has been correct, but I messed up the end behavior, which is why I ran into an issue. So that's what's great about knowing all these different rules, because they conflict with each other. So if you mess up on your zeros, then it won't really go with your end behavior, and you know something's wrong. So I apologize for that. So the end behavior should be up on both ends, because the leading coefficient's positive, and it's even. Alright, sorry if I said opposite directions. Alright, so it's going to go through 3, alright, because there's normal behavior through that 0. It's going to go through this y-intercept. It's going to bounce off 1/2 because the multiplicity of 2, and then come back down and go through 1.